I hope I am audible to all.
Yes, sir.
Fine. So I was discussing about in case of any remote sensing system, there is a requirement of energy source. Okay. So whether it is passive imaging system or active imaging system, in both cases, energy source is required. Okay. And that source generates energy. Okay. So like in case of satellite imaging system, it is a passive in nature. Okay. And sun is used as energy coming from the sun is used for the imaging. Okay. When we consider the active imaging system, like when you do photography night, okay, so you switch on your flash, and once you click it, so the energy light is generated from flash, and that light impinge on the target, and there is a reflected energy. That reflected energy is sensed. Fine. So in this introduction, there is a basic discussion on the energy source, how that source generates energy, that energy propagates in the medium. Okay. Here in case of satellite imaging, the medium is atmosphere around the Earth's surface. From the sun, energy emanates. Okay. It enters into the Earth atmosphere. It passes through that, and then finally it reaches to the Earth object. Okay. Now further, when that energy interact with the Earth surface objects, it is reflected back, and further it is sensed by the sensors inbuilt with satellite imaging system. Okay. So there is a brief discussion on that, and type of sensors, what are the mechanism through which we acquire the images. So what are the type of sensors? Okay. In case of satellite based imaging, how that sensors move forward so that we can cover the entire globe. Okay. Then there is a term pixel. Okay. So could anyone tell me how we define a pixel in the context of when the sensor system acquire the images, and once you analyze the image, how we define pixel in that image?
Pixel is the smallest addressable element in a raster image.
Okay. Briefly, though I will cover it in detail. If you see over here, the figure 1.1, I hope you can see. Okay. So this is figure 1.1 is the architecture depicting how that imaging system that is mounted with a platform acquire the images. Okay. So sensor is a combination of certain charge coupled devices. Okay. So in CCD, a particular detector has a square shape. Okay. So this detector looks at the ground. Okay. And it covers a very specific area on the ground. As you see over here, let's say P is the center point of the ground element. Okay. So the energy content which is reflected back from this area around point P, it goes to the scanning mirror that is inbuilt with the sensor system, and further it is detected by the square shaped detector, and there are multiple square shaped detectors combined together. We call them CCD, charge coupled devices. Okay. So it's for the brief understanding, like what do you mean by pixel when we see the image. As we discussed in the laboratory course, like once you zoom in the images, what happens? After certain level, you can see the pixelated version. okay, where you can see the square block, and that is square block is painted. If we consider the grayscale image, so that is square block is painted with a particular shade of gray color. Okay, so that square block is actually representation of a ground feature in a very smallest area that is uniquely defined. So the point P, around this point P, a certain area is defined, okay, and energy, that is energy comes from the sun. As I discussed before, the workflow of energy enters into the earth atmosphere, reaches to the point P, reflected back towards detector over here, okay. So that energy reflected from the entire area, okay, that is around point P, is sensed by the detector, okay. So it is a kind of a footprint of detector on the ground, how much area the detector can see on the ground, okay. So in this way we define the pixel. So pixel is the representation, digital representation, okay. It's a ground area, okay, that is smallest unit, smallest ground area unit, okay, that is uniquely sensed by the sensor system, and that is assigned a unique digital number, okay. It is called pixel. Okay, so pixel is represented by a unique digital number, okay. Now let's say if we acquire the images in two band, I hope you have also gone through the electromagnetic radiation, okay, that is very wide range, extending from X-rays, gamma rays to radio waves, okay. So within this very large range, we select a discrete energy bands, okay, to design the sensors, okay. So these discrete bands we use for acquiring the images. Let's say we have a two discrete number of bands, okay. If we have a two discrete number of bands, then from the same ground area, the energy which is coming to the sensor, like see over here. So how many detectors we require? This is a kind of general discussion with you based on your understanding, basic understanding. Let's say if we select a two discrete band to sense the information coming out from point P in terms of energy content. If we have a two discrete band, then how many detectors we need? And what should be the property of the detector? Alok. Alok Kumar. Whatever you know, you can just briefly share your views, your ideas behind that. Alok, the query is there are two there how many detectors we require to sense the energy coming out from point P in two discrete band. Let me further clarify it. When our eyes see the object, so the object reflect energy in very wide spectrum, okay, but our eyes only limit the sensing within the visual band. So our eyes sense separately the red band, green band, and blue band, and finally assign the color accordingly, and mixing the color, then we see the object of the color. It means if our eyes sense three discrete band, so three different we can say the sensing capability is required. Separately, the red band energy is sensed, blue band energy is sensed, and green band energy is sensed. So there is provision in our eyes to sense separately energy coming in these three bands. Okay. Similarly, when we consider the artificial remote sensing systems, so in that case, this detector sense in a one particular band. If we have another band, so in both band to sense the energy coming from this point P, how many distinct detector is required? Now I hope it is clear.
Sir, two.
Two.
For
And why two?
for each band we need a separate detector.
Yes. See over here, one analysis we are doing in spatial domain, like we defined pixels in spatial domain over here. So spatial domain means on the basis of area covered on the ground, we define pixel. Okay. But what value we need to assign to pixel, that is defined on the basis of energy content. Okay. When we consider the energy content, then that energy content varies from one wavelength to another. How it varies? Just I'm going forward over here. As I told you to read it, so I hope you have gone through that. All of you have already read about it in your 12th standard, like energy is equal to Sc by lambda. Okay, where H is Planck constant and lambda is the wavelength. So when we consider the photon, that is a smallest unit in the light. So that photon energy of a single photon in case of larger wavelength is less compared to the short wavelength. Okay. Therefore, when we move from one wavelength to another wavelength, the energy content varies. Okay. And this is one of the reason, like if there is a larger wavelength, so at larger wavelength, energy content will be less in one photon compared to the shorter wavelength. Okay. So what is the role of it over here? When we are going to assign a distal number to the energy content, okay, at point P, so that distal number is assigned on the basis of energy content. Okay. And energy content at larger wavelength is less compared to the shorter wavelength. Okay. It also depends on the reflecting capability of the feature within around point P. That we'll see later. So another analysis is in terms of along the axis, wavelength axis. So spatial domain analysis, we defined a pixel that is uniquely a unique smallest area element that is uniquely sensed. Okay. So what is the value assigned to that smallest area element in terms of its distal number? That value depends on how much energy is coming out and in which particular band we are sensing that energy. Fine. If you sense that energy in the larger wavelength, so energy component will be less. compared to sensing that area in shorter wavelength. Is it clear? Again, this is very generic discussion. Rahul Kumar, could you please unmute?
Yes, sir.
Is it clear to you?
Yes.
What I discussed?
So wavelength and photon and energy band.
Sumit, could you please unmute? Sumit Pandey. Abhijit Sonkar, are you there?
Yes, sir.
What I discussed?
Yes. Yes.
Sumit, now you can wait. Yeah, Abhijit, carry on.
So larger wave has less energy, and shorter waves have more energy.
Correct. See, when we see the electromagnetic radiation, okay, when we analyze the EMR radiation on wavelength axis, okay, Abhijit, you can unmute. Be in unmuted mode.
Yes, sir.
Okay. So I hope all of you have already gone through the band and its wavelength. So if you see along the wavelength axis with respect to the increasing wavelength, shorter wavelength, the energy coming from the sun at shorter wavelength, we have a gamma rays and X-rays. Then visible band comes. After that, we have a near infrared, mid infrared, far infrared, and it will goes to the radio waves. Let me see whether it is plotted. Okay. So what I said before, the sensors which are the part of imaging system, those sensors are designed in a discrete spectral band. Okay. Now let's say if we select two spectral band and we sense the same smallest area element. Okay. So the energy which is coming out from that area element, it is available in all the wave band. Okay. Varies from your visible to radio waves. But as I said before, our eyes can filter out all the radiation outside the visible spectrum. Similarly, in case of sensors which sense the energy in every band, so each band sensor has a filter and it filter out and all the energy content which is outside the band. Let's say if we select a red band, if that sensor is designed for red band, so it only senses the energy coming out from the area in red band. Okay. Let's say if this detector is designed to sense energy in red band only, it will discard all other energy component and sense only the red band energy. Similarly, if you designed it for the near infrared band, it will discard other energy component and it will sense only the energy within the near infrared band. So if you design your sensor in red band and near infrared band, if you are going to sense the energy from this pixel P, okay, in red band and near infrared band, So two separate detectors are required. This was my query initially. One detector is designed in red band, another detector is designed in near infrared band. Okay. Near infrared band detector discard all energy outside an IR band, and red band detector discard all energy outside of red band. And from area at point P, energy coming out towards detector in all the bands. But now it is a capability of detector to discard rest of the band and only sense in which the detector is designed. Okay. Now the second point, energy which is coming out from area P. Okay. So that energy which is coming out from area P, in that energy, if it is at larger wavelength, so that energy content is less compared to the shorter wavelength. Okay. Now my second query, which I also suggested you to go through that. Okay. Can we do the remote sensing in gamma rays or X-rays? Sumit, you can respond.
Sir, gamma rays have a larger wavelength. They will have a less energy content.
No. Gamma rays and they are shorter wavelength. Their wavelength are less than visible.
Okay, sir.
That's why I told all of you, kindly learn the wavelength axis. That is a different spectral band. This is
Okay,
very
sir.
important. You should always remember, if I speak about visual spectrum, then what is the wavelength range? If I say gamma rays and X-rays, what is the wavelength range? If I say near infrared band, what is the wavelength range? Similarly, for far infrared, thermal infrared, mid infrared, and radio waves. Okay, now carry on. I told that its wavelength is less than visible spectrum. Can we do the remote sensing? This is a logical question based on the general learning you have already done previously. Yeah, continue.
So actually, I don't know the wavelength of X-rays. That is why I cannot. I'm not able to speak it on it properly, sir.
See, wavelength of X-rays and gamma rays are less than visible spectrum.
Okay, so then we can
They are
use it
short
for
waves.
we can use it for remote sensing because they will have large energy content.
Sir,
Yes,
are gamma rays and X-rays different?
they have a different band. They are designated in different bands. Who is going to respond? See, the basic requirement for sensing smallest ground element, sensing the Earth surface object, is to get the reflected energy component from that area element. Fine. Does we get the reflected energy in gamma rays or X-rays from the Earth surface object?
Sir, yes, sir, both.
Alok, would you like to respond? Does our atmosphere allow gamma rays and X-rays to pass through?
No, sir.
Because, yeah, Abhijit, you want to say something?
Sir, gamma rays, X-rays can be controlled, but gamma rays cannot be controlled because it is emitted from the radioactive decay of the atom.
Let's say if we consider the X-rays, which is coming from the sun. So does our atmosphere allow X-rays to pass through?
No, sir. Sir, even UV rays cannot, most of the
Can't
UV rays
pass.
cannot
Fine.
pass from
Because
the
they are
ozone layer.
not, yeah. Our atmosphere only allow, again, see over here, our atmosphere is also acting as a kind of filter. Okay, the ozone layer totally, ozone layer stop the ultraviolet radiation. Okay, and even the short wave radiations are not allowed by the upper layer of atmosphere to pass through. So already there is a kind of filtering by the atmosphere. Atmosphere doesn't allow the wavelengths which are less than visible spectrum. Okay, atmosphere allows only the wavelength within the visible spectrum and wavelength more than that.
Sir, I have to ask one question.
Yeah.
Sir, sir, the gamma rays are and X-rays are stopped by the magnetic field of the Earth or the ozone layer.
See, how magnetic field stop gamma rays and X-rays? I mean, see, upper atmosphere, the upper atmosphere trap are stopped all the radiations which are less than visible spectrum in terms of wavelength. Okay, so they are not allowed to pass through. So I don't know how this magnetic field comes into the picture over here. So the remaining energy content which is allowed by the atmosphere, they goes to the Earth surface object. Okay, and there is a interactions takes place and we have a reflected energy. It means when we don't have any reflected component in these spectrum, though if you see that they are the short wave and energy content is more, it means in a very small area you can get enough energy content in the reflected energy. Okay, but these radiations are not safe for humankind, and nature designed the system in such a way that they are not allowed by atmosphere to pass through. Okay, so if we don't have any reflected energy component, so in that particular spectrum we can't design the sensors, and it is not hypothetically we can say, but in the real case, due to the safety issues and due to the nature based architecture which we have, it is not there. Now similarly, it's one end problem, we can say it's boundary problems. So it is one side of the spectrum, and if we consider the lower side of the spectrum in terms of wavelength, can we do the imaging in radio waves? Or can we do the imaging in microwave range?
Hello, sir.
Yeah, Alok.
Sir, I think it is not possible because these rays are having very high wavelength, but they have very less energy. So our
Correct,
detector
correct.
will.
Yes, when I consider the microwave, in microwave can we do? In microwave, we can acquire the images, and it is a very large scale mapping. Large scale mapping of homogeneous features. Like if we are going to map about the ocean currents, all of you have already seen the atlas, okay, oceans in terms of different currents which we have in the ocean, okay. Those large scale mapping of uniform kind of feature can be done in microwave range, okay. Though when we talk about this ground element, okay, that pixel, so we define an smallest area element which can be uniquely defined in terms of a distinct decimal number, okay. So that area element size will be very large in case of microwave band. Why it is? Because in microwave band a particular photon has very less energy, so the energy which is reflected back, the detectors should have a sufficient energy to sense, okay, to generate a equivalent digital number, okay. So we require a very large area so that enough energy will reach to the sensor, and further it will generate electrical signals and it will generate a equivalent digital number for that area, for that pixel. Okay. So from a particular pixel I am considering here the smallest area element. If that pixel is acquired in only one spectral band, so how that in the image, how that area is represented? It is represented by a vector 1 cross 1 because we have only one band. Let's say if it is acquired in 3 band, same area element, it is acquired in 3 band, then what will be the size of pixel in that case? Who is going to tell me? Again, this is a general query. Bhagat Kumar, could you please unmute?
Yes, sir.
Question ये है कि at point P we have a smallest area element, that is pixel, okay,
Yes, sir.
and energy coming out from that area element is sensed by the 3 detectors, and
Yes, sir.
Each detectors are designed in a 3 different band. So how many unique digital number will be collected?
So what do you mean band?
Band means when we analyze electromagnetic radiation. So in electromagnetic radiation, it is comprised of a infinite band wave band, infinite number of wavelengths.
Yes, sir.
Okay, varies from gamma rays, X-rays to radio waves. Okay,
Yes, sir.
so there is a wavelength axis. Okay, on the wavelength axis we have a infinite number of wavelengths.
Hmm.
Certain discrete wavelength range we select, like a red band. Red band means certain, let's say, 0.78 to 0.7, 0.7 to 0.78 micrometer. Then further in near infrared, one discrete band we select, and similarly, let's say one in mid infrared band. So these bands are used to design the detectors. It means only the energy coming from the area A, area from point P. So that energy is sensed by in red band, in near infrared band, and in mid infrared band. Is it clear?
So basically all the band will collect individual data.
Yeah, individual data they will correct individual energy. They will sense
Energy, yes,
energy
energy
coming from
band.
point.
Yes.
Yeah, energy
Yes.
coming from point P is available in all the band. Okay,
Yes,
but the
yes,
detector only sense energy within the band in which it is designed. So
yes,
there
sir.
are 3 detectors designed in red band, near infrared band, and mid infrared band.
Yes, sir.
So how many digital number will be acquired from that area? Distinct digital number. One detector sense distinct energy, and one digital number is generated. We have 3 detectors. Then how many digital number will be generated separately?
3, sir.
Fine. So just see, in spatial domain, we have only one area unit. But that area unit reflect energy in wide band available at each wavelength. Okay.
Yes, sir.
Now our sensors are designed within a specific band, and I hope you understand the definition of band.
Yes, sir.
Like we select a discrete range of wavelength within the on the wavelength axis. Okay. So one is at the red band, near infrared band, and mid infrared band. So the band which is in near infrared band, it sends the energy within that band only. Because once the energy comes from sun, interact with point P, it reflected back the energy in all the wavelengths. But the detector which is designed in near infrared band sends energy only within that band. Okay. So after sensing the energy, equivalent digital number is generated. Similarly, another detector which is designed in near infrared band, it will sense the energy within that band only, and a different obviously energy will be different. You can mute now. So when in another band, energy will be different obviously because it is in different band. So energy varies with respect to wavelength. As I said before, one of the reason is energy available in one photon. So if you move from short wave to long wave, at that case what will happen? Energy within a photon will decrease. Okay. So in red band, energy will be more. It also depends on the reflectance capability. Let's say we assume it's an ideal surface where all the energy is reflected back. So in that case, in the red band, energy will be highest, then energy will be decreasing in near infrared band, it will further decreases in mid infrared band because the wavelength is monotonically decreasing. Sorry, wavelength is monotonically increasing. Okay, so the different digital number is generated in NIR band, and further different digital number is generated in mid infrared band. Okay, so for the same area element, we have a 3 different digital number. And now it is the pixel is represented by vector 1 cross 3. Okay, so 1 column and 3 rows, and each row indicate a band. So a column represent a particular pixel, but row indicate the band. Is it clear? So briefly, I'm discussing about the digital representation of area in terms of digital number. Now let's say if we have a 7 band. Abhijit. Abhijit, could you please unmute?
Yes, sir.
If we have a 7 band, then what will be the representation of digital number?
1 column and 7 rows.
Correct. 1 column and 7 rows, where each row represent the
Band.
digital number acquired in that particular band.
Yes, sir.
Okay. Now again, we need to take this. Okay. Okay. Further in section. In section 1.2 and subsection 1.2.1, there are certain standard terminology that we use for the energy propagation from energy source to energy target, that is our surface object, and sensor. Okay, so you need to read these the definition of these terminology. Okay, as well as I suggested, you should remember the band characteristic of each band, okay, which are defined along the wavelength axis. So band characteristic means if I say the visible band, visible spectrum, and within the visual spectrum, if I talk about red band, green band, and blue band, so you should remember what is the wavelength range for blue, what is wavelength range for green, red, etc. Okay. So till now we have discussed about how we define a pixel, okay, in the spatial domain with respect to the ground. Okay. Further, how we can uniquely assign a digital number, how that ground area, how that pixel is represented in the image. So it is represented in image in terms of digital number. Okay. So how that digital number is generated in multiple bands. Okay. What is the working principle of sensor in multiple band? Okay. How we can generate a distinct digital number in a different band? What is the reason for that? So we discussed that if we move from shorter wavelength to longer wavelength, then energy within a photon is decreases. Okay. So this is the reason why in case of microwave band, there is very less energy in one photon. That's why we need to have very large pixel area, very large area on the ground, that is assign a unique digital number. Why that large area is required? Because the sensor requires a certain level of energy to sense, to generate output. Okay, so to reach up to that energy level, up to that threshold, we need to increase the area of ground element. Okay, so that pixel area that we define on the ground, that we increases in case of, and it will goes in kilometer. So it is a kind of 1 kilometer by 1 kilometer patch on the ground in case of microwave. Okay. So it's a general discussion why we need to increase the smallest area on the ground when we move from shorter wavelength to longer wavelength. Brief discussion we had on that. Okay. Then further we discussed about uh, discretization of bands. Okay, how we select band on the wavelength axis. So do you have any further query related to the previous week discussion?
No, sir.
No, sir.
I think we had discussion on this slide, and now it will be more clear to you. Okay. When we talk about the radiometric detail, it means the transformation of uh, information which is there within a Earth surface object, okay, into the equivalent digital number. Okay. So we define a pixel over here. It is the smallest area element on the ground. That is just over see over here. This smallest ground area element, and it is uniquely represented by a digital number. It means within that area element, though you can expect the multiple features, but that can't be differentiated, because in the image unique digital number is assigned. It means it assumes that that area element has same feature. Like in case of microwave remote sensing, as I told that the size of area element goes to kilometer. Okay, it means if the area element is 1 kilo by 1 kilometer square patch, and in the image you represent it by a digital number, unique digital number, it means there is a number that is constant. So it is considered that 1 kilometer by 1 kilometer area patch has the same feature that can't be further differentiated. That is the reason why I told that in microwave remote sensing we generally map the homogeneous features. Okay, it means the similar kind of features, and they vary at very large I mean that vary at very large section. Okay, that not varies very frequently in the spatial domain. Okay, like a kind of glaciers mapping. Similarly, that I told that the different currents in the ocean, they are mapped in microwave remote sensing. But when we talk about the urban features mapping and their classification, then obviously in that case we need to have a meter level area element. That size should be in meter, okay, or even it should be in sub-meter, okay. Let's say if you want to identify the building's roof in the images, okay, and the smallest building roof size is, let's say, it could be 7 meter by 7 meter, then what should be the pixel size? The smallest building has area 7 meter by 7 meter, okay, roof area, and all other buildings roof area is more than that, and your aim is to identify the building roof in the images. And what should be the size of uh, ground element corresponding to a pixel? Who is going to tell me?
So depend upon the requirement and detail.
नहीं, requirement ये है कि let's say if you are working in a company, okay, and you have given a task like you need to purchase a imagery, okay, and objective is to, in that imagery you need to identify the building roof, okay, and the smallest, then what should be your approach for that? How you select the type of imagery? And only one aspect I am asking, that is how you select imagery in terms of the smallest ground area element size that is defined as a pixel. Yeah, Alok, I think you can respond. You are already working in the same domain since long time.
Sir, I think the smallest area of the roof is 7 cross 7. Hello?
Okay, that is fine. That what you will select the pixel size.
Sir, I think
Okay, I suggest you to go through this. The first question in the next lecture, I will ask the same. Okay, we'll have a discussion from this point. See, I mean, the basic things I have already, just you can see in this image. Let's say there is a building you can see over here. Okay, and this roof you want to get in the image. That roof you want to identify from the image. Okay, it's a very general kind of query. So how that can be, what should be the size of pixel in the image? Okay, so I expect all of you will go through this, and I can ask anyone, even I can ask, I expect a response for this from all of you. So I stop my discussion over here, and
Sir,
yeah, Rahul.
sir, it's depend on bandwidth which detect by detector. The roof size, pixel size. Maybe
Yes,
depend on
Hani,
bandwidth.
you are correct.
Yes.
This is a secondary parameter that we consider. See, obviously,
Yes.
7 that pixel size should be less than 7 meter by 7 meter. Fine, because 7 meter by 7 meter is the area of smallest roof. So to get pixel size less than 7 meter, so obviously we need to select a band in which the objects which are there in the scene, their energy from the at least from the 7 meter area size should be recognized by the detector. Okay. So the selection of band will be decided on this basis, like in which band uh, you need to select, in which band you are going to detect the building roof. Okay. So this is a secondary parameter which this is another parameter which you further consider. Okay. But the first parameter that is most important is uh, if let's say in your image the size is 10 meter by 10 meter, if it is a size of the pixel, so that can't be give you the accurate result. Okay, think about it, and we'll have discussion on this in the next session. Thank you very much for joining this lecture session.
Thank you,
Thank you,
sir.
sir.